So first thing that we're going to do is theoretical, and theoretical is what we've been doing. So when it asks you to find the theoretical probability, it's just asking you to find what we've been doing. What is the normal probability of what we do? In theoretical, what word do you see, or what word does it kind of look like or sound like? Theory. What does it mean to have a theory?
Like it's something that hasn't been proven yet.
Yeah, kind of something that you think will happen, something that's not proven necessarily yet. And actually, a theory is something you can prove. It's interesting. In math, theory are things you can prove. So in theoretical probability is what should happen mathematically. Yikes. Okay, what should happen mathematically? Who just walked in and out? Okay. So, when we flip a coin, how often should you get heads? 50% of the time. Now, does that mean if I flip a coin 2 times, I get exactly 1 heads and 1 tails? No, I could get heads both times. So that's not what exactly happens. Theoretical is what should happen. Okay, experimental that's where we do the experiment, is what actually happens. Now, we're going to run 3 experiments with 3 different things. It might take a little bit of time. It might be a little putsy, so I might need some help with some volunteers. Okay. First thing we're going to do is we're going to draw a card. Now, when we see that term, draw a card, does that mean everyone's going to do the best they can to draw a picture of the card? It just means pick a card. Yep, good. Okay, so when you see draw a card, that really means pick a card. Okay, we're going to need people off their phones today because we have actual experiments that we have to actually run. All right, I want to know what is the probability of drawing a queen. So first I'm going to figure out my theoretical probability, which is what we can do without actually having to do the math. We can just do this based on knowledge. So if you're not sure about a deck of cards, I have the deck of cards drawn up on the board back there. How many queens are there in a deck of cards? 4. Out of how many cards total? 52. So our theoretical probability is 4 out of 52. And then we can simplify that using Desmos. And we get 1 out of 13, which makes sense because how many, there's 13 different cards like ace, 2, 3, and how many is a queen out of the 13? 1. 1 out of the 13 is a queen, right? So 1/13, which has a decimal, is 0.07692307692307692 307692307. No? Yeah. Thanks. All right, so if I round that, do I want 0.07 or 0.08? 0.08. What's that as our percent? 8%. If we're not sure, we can always do times what? 100. So when I do times 100, I see 7.6, which tells me to round up to 8%. All right, now we're going to do our experimental, okay? In our class, we're going to pick a total of, how many of us are there today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 of us. So we're going to pick 23 cards. So out of 23 cards, we should get a queen 8% of the time. So we're going to do 23 times, and we're going to multiply by our probability. We can either use our fraction, our decimal, or our percent. You guys want to use the fraction, the decimal, or the percent? We could use the decimal, 0.08. In my calculator, I want to try and use that per decimal I already had in there. So that 0.07692, whatever it was. So I'm going to say times 23, because there's 23 of us in class. And we get about 1.7. So while we draw cards, if we draw cards 23 times in this class, we should get a queen 1.7 times. So I'm going to come around, you're going to draw a card. We're going to see how many we get our queens. Good queen? Good queen? Good queen? It's not impossible, there's queens in there. There you go. Sorry. Oh, we got one. How exciting. Try and get the exact same one. Oh, a different queen. We got two. That was impressive. 2 queens so far. You're only supposed to get 1 point. Shouldn't get any more, but we'll find out. Oh. Nope. That's our queen.
6 o'clock, that's easy. Grass,
Nope. How fun is this? This is a really fun game, isn't it? This one for me. No. We've gotten a lot of 10s, which is weird. No? No queen? No queen. Queen? No.
No, just stop it there. It's not going to happen.
I got 2 more. It might happen. Jack. Ooh, face card, but not. And then my turn. Not a queen. So we got 2 queens. That happened for us 2 times. So for our experimental probability, did it happen the amount of times that it was supposed to happen? Yeah, we can't really get a queen 0.7 times, so it was really 1 or 2 times. So for our experimental probability, we got it 2 out of... Now, it's not out of 52. We want to go out of how many times we ran the experiment. So 23. So 2 out of 23. Can I simplify 2 out of 23? I don't think so, but let's see. So clear that. 2 out of 23. Yeah, 23 is prime, so nope. Okay, as a decimal, I get 0.08695. So do I want 0.08 or 0.09? 0.09, which is what percent? 9%. So it's supposed to happen 8% of the time. And how did it happen with us? 9%. Now that's pretty crazy. In my other classes, we did like a spade or a heart. And when you look at our data, we were pretty far off. Like in this one, we did probability of a heart in my period 3. and we did 20 cards, and it happened 15% instead of 25%. So it's okay if your experimental is a little off. It just so happened we were right on, which is awesome. And the more times we pick cards or the more experiments we run, the closer we should get to that 8%. All right, next up, that was experiment number 1. Experiment number 2 will hopefully go by a little bit faster. We're going to flip a coin for number 2. Alright, and because I didn't want to give you extra money, because I knew if I give you guys money, you weren't giving me the money back. Some of us like to steal things like flags. Just kidding. I'm joking. You didn't. I know. I'm joking. Alright, so with this circle, or with this coin, what are my 2 sides? Red and yellow. Alright, which one do we want to find? Red or yellow? I heard more yellow. Sorry. Alright, so we're going to find the probability of getting a yellow. We'll start with our theoretical probability, which is just the probability that we have been doing this whole time. So theoretically, how many sides are yellow on my coin? 1 out of 2. And can I simplify a 1 out of 2? Nope. And this one we should have memorized. 0.5, which is 50%. It's our half and half. Even chance. Okay, there's 23 of us, and we are all going to do this 5 times each. So 23 times 5, 15, 11. So we're going to do this 115 times. 115 flips. So with 115 flips, first we're going to predict how many times out of 115 should we get yellow, theoretically. So 115 times, and we can do times the fraction, the decimal, or the percent. Let's do the percent this time. We did the decimal last time. So if I do times 50%, I just wanted to show you the decimals also. When you do percent in decimals, if I do 115 times 50, but we need that percent, decimals puts the of after the 50. So you always have to put the percent first. So if I was doing 50% of, the of means times 115. And that's 57.5. So we should get about 57 or 58 yellows when we do this all together. Okay? We're going to count our rounds together to make it easy. So everyone needs a coin first. If you want to practice flipping, you can. Billy, Bucky, you guys ready to do this with us? So you can go ahead and practice for a second if you want to, see how it feels when you flip it. But we're going to be doing it all together in just a moment. Okay, come on, you're going to do this with us. We need you. We need you. Alright, so when you flip this one, because it's foam, it doesn't really stay on your finger too well, so you kind of just throw it up in the air. Just make sure you throw it up high enough that it has a chance to flip if it wants, but don't throw it crazy so that it goes all over the room. Try and keep it in front of you. Alright, we're going to do this all together. We're going to do our 5 rounds together, so everyone has to flip it, and we're seeing how many times we get a yellow, okay? I'm going to keep track on my phone how many times we get a yellow on my calculator. So, everyone flip your coin the first time. This is our first round. Everyone flip it. Alright, raise your hand if you got a yellow when you flipped it. Flip your coin. Raise your hand if you got a yellow. Did you flip your coin? Just one time. Okay. Fati, did you flip your coin?
Red game.
Flip your coin. Did you get a yellow? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's our first time. We're going to do this 4 more times. So everyone pay attention and do this with us. Everyone flip your coin. Dorian, flip your coin. Nope, I didn't really. Okay, raise your hand if you got a yellow. 4, 5, 6, 7, 8, 9, 10. Only 10 of us that time? Okay, flip it again. That was 2 times. This is our third. Oh, I got yellow again. Raise your hand if you got yellow. Bati, did you flip your coin again?
Yellow game.
Do you flip it again? 4, 4. Raise your hand if you got yellow. Did you guys flip your coins?
We got yellow.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 that time. Okay, 2 more. Flip your coin. Raise your hand if you got yellow. Flip your coin again. Fatih, flip your coin again. Raise your hand if you got yellow. You got red. Don't raise your hand. 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, last one. Flip your coin. Last one. Raise your hand if you got yellow. I almost got yellow every time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, so all together, we got a yellow 66 times. So was that more or less than what we expected? More, so we should have betted on that we were going to get yellow. Alright, so our experimental probability I added it together in our calculator so we could do it more times. We had 66 out of how many flips total? 115, as long as everyone actually did their flips. So in our calculator, we'll do 66 over 115 and see if we can simplify that. And it doesn't simplify. So as a decimal, it's 0.5739130435. So would that be 0.57 or round to 0.58? 0.57. So even though it seems like we were pretty far off, 66 and 57 kind of seem like a lot off, we were within 10. And really, what percent is 0.57? 57%, which is actually in real life pretty close to 50%. Okay, depending on what we're doing now, if we were deciding if you're going to live or die, okay, 57% is not pretty close to 50%. I don't know if I'd risk that. Okay, but if being that we're just flipping a coin, it's like low stakes, right? All right, we have one more thing we're going to do. One more experiment we're going to run. Number 3, we are going to roll a dice. Last one for today. I'm going to try to not take up as much space. All right. When we roll a dice, we're going to do our probability of rolling. What number do you want on the dice? 6. Okay, probability of getting a 6. So theoretically, how many 6s are there on a dice? 1 out of 6. Now that's if we use a normal dice. Depending on what game you're playing, you might need to double check your dice, right? Like if you're playing Super Mario Party on the Switch, Nintendo Switch, depending on the character you pick, some of them, they have like different amounts of numbers, right? And you guys play Super Mario Party on the Switch? Oh, okay. Well, Super Mario Brothers is like my favorite. So 0.166666666. How do I show that 6 is repeating? The little line. But if I wanted to round it to the nearest whole percent, yep, and I can do times 100, and that would be 16 or 17? 17%. All right, now there's 23 of us. We are all going to do this. We're all going to do this 10 times each. So if there's 23 of us, how many times would we do it together? 230 times. So we're going to do 230 total. So we're going to take 230 and either we multiply it by the decimal, fraction, or percent. We did the decimal, we did the percent. Let's just do the fraction just for the sake of our notes to show that we can do any of them. So 230 times 1/6 is 33.333333. So it should happen about 33 times for all of us. Okay, now you're going to keep track yourself. So one way that you might want to keep track is if you, on a scratch paper or on a whiteboard, make like 10 total tallies. And then when you roll the dice, if it's a 6, like circle it. If it's not a 6, cross it out. Because you're going to have to keep track of doing it 10 times. And you have to keep track of how many were 6s. Does that make sense? So don't just keep rolling until you get 6s. You get only 10 rolls. And out of the 10 rolls, you have to decide how many of those 10 were 6s. Yeah, Gabby, what? What? You got 38? Oh, I did times 200. Why did I do that? You're right. I'm sorry, you guys. Times 230. I don't know why I put in... It should be 38.3. Sorry. Make that little 3 into an 8. What?
I got 619.
Oh, no. You already did it? Yeah. Okay. All right, so go ahead. Once you get your dice, can you share those with your people at your table? Thank you. All right, once you get your dice, you're doing it 10 total times. You need 10 rolls. Okay, you're listening? You got to do this. You got to roll 10 times. Now, how many times you get 6? Only get 10 rolls. Yes, everyone's doing it. Wait, I got to count yours. All right, so you're doing 10 total times. If you need to keep tally, keep tally. Oh, you guys got yours. Did you get one out of that? All right, so roll it 10 times and decide how many times you got a 6. Billy, you can do this. You need your Pati to do this with us? So we're rolling it 10 times and then 6s. 1, 2. Do it again. You gotta do it 10 times. 3, 4. Come on, we gotta do it 10 times. 5, 6, 7, 8, 9, 10. We got 60 now. Alright, how many did you get? 1. Billy, how many did you get? 0. How many did you get? 5. How many 6s did you get? Roughly 0. How many did you get?
Your chair is on for no
Did you roll it 10 times? Yeah, you have to roll it 10 times and count how many 6s you get. What did you get? 2? If you fill out that.
Wow.
You had 6 out of 10 times. You got 6? Yeah. Whoa. What did you get? 3. What did you get, Gary? 1, 2, 2. Did you roll your dice? We haven't started yet. No, 1 dice, 10 times. Where's the rest of it? So roll it. 1. Okay. 2. 3. Yep, 6. 4. 5. Yep. 6. 7. 8. 9. You got 2 times. Alright, what'd you get? 2. What'd you get, Ryan? 2. 0. What'd you get? 1. What'd you get? 2. What'd you get, Winner? 3. 1. Honest, what'd you get? 3. Awesome. Alright, all together. Whoops, sorry. Holy cow, we still are just way above and beyond. We are extra today. We got 50 all together. That's crazy. I went around and counted and put it all in. So for our experimental probability, the hardest part isn't going to be to find the 50. The hardest part is to remember how much it's out of. So is it 50 out of 6 options? No, it's 50 out of how many times we did it. And how many times did we do it? 230 times. Which, was that close to 38.3? Kind of. It's not like super close, but like close-ish. It's within 12. I don't know. Alright, so 50 divided by 230. Throw that in our calculator, see if we can simplify that. And that would be 5 out of 23. Which, as a decimal, would be 0.217391343. So what would we round that to? 0.22. Okay, really important that when we're doing our percent, we're not just going off of that first number. Percent, we want to use both a 10th place and the 100th place. So it's not just going to be 20%, it's what? 22%. I noticed some of us on our test yesterday did that. Okay, some of us on our test yesterday also got a lot of right answers to somebody else's test. It's very suspicious. So if you got a score that you weren't expecting, that's probably why. Alright, so 22%. So 50 feels like it's really far off of 38, but when we compare percents, I have 17% and 22%. Are those pretty close to the same? Yeah, they're only 4% off, yeah. 5 off. They're only like 5% off. We're pretty close. Either way, is it impossible, unlikely, even chance, likely, or certain? They're both unlikely, so we're pretty much in that same category, so it's okay that we're a little off. That's always going to happen, usually in real life, okay? Now, one time